Domain and range are just referring to if you have a very basic function, for example, so you should already know what a function means by now. It just means any particular instruction that you give to an x for an input that creates an output. In simple terms, if you have f of x equals to 2x plus 7, for example, if you were to not introduce anything as is, as in if you just wrote it like this, we just assume you're allowed to make this anything you want. And whatever, depending on the x is going to be, this answer is going to change, depending on whatever that x value you substituted into here is going to be. Very typically in exams, you're going to have something like f of x equals to 2x plus 7, comma, if you write down 4, x bigger than 2, you see the significance of this? What you're really focused on over here, right, for this tutorial is, if you see this particular condition for x bigger than 2, you don't just sort of ignore it. You have the awareness that, oh, I understand the implication of this. As in, what this really means is the number that goes inside over here now has to be bigger than 2. And therefore, if the number that goes inside of here has to be always bigger than 2, doesn't that change what numbers this overall answer can be? Compare this to what it was previously. If you have f of x just as is equal to 2x plus 7, this can be any number right now, can't it? 2x plus 7 can equal to 69 if you wanted to. You just change what the x value is going to be. As in, if you change the input, which is the x value, to a particular number, you can create indeed an output of 69. Just like if you have 2x plus 7 is equal to 420, doesn't matter. Like, you can change this x value over here to create an output of 420 is my point. But the moment you write down 2x plus 7, comma, f of x equals to that, x must be bigger than 2. Do you understand this overall number that you get, overall answer you can get? It can't be anything anymore. It's dependent on what? The thing that changes over here, which is the x that goes inside, which now can only be bigger than 2. See my points? So domain is just telling you what the number that you're allowed to put inside, exactly what it's limited to now. X bigger than 2 is what we mean by the domain then. Domain is just referring to what exactly is the input allowed to be. If you have f of x equals to 2x plus 7, comma, 4x bigger than 2, then the domain is x bigger than 2. Because domain is just how we describe what the numbers that you're allowed to substitute, allowed to input into the function are allowed to be. By case, describing what the x value is. Okay? That's all it is. Describing whatever the x value is allowed to be. It is a limited representation now. And range over here is just describing what our overall answer is allowed to be. Obviously, if you say that x has to be bigger than 2 when you substitute into here, the range is going to be different. And range is just telling you exactly what those numbers that this can take on is going to be. And if you're wondering how you go about doing that for this question, if you have f of x is equal to 2x plus 7, you can go about doing this by thinking about if you replace the x over here with 2, because if it says x is bigger than 2, why wouldn't it make sense to start off by plugging 2 into there? Where else would you look? Isn't 2 the smallest number in this context? Because you get that x bigger than 2, there's no real limit to how big it can be. I'm explaining to you the logic, sort of comprehension here. As in, you interpret this as, well, if it's bigger than 2, you don't bother looking at the different numbers that it can be bigger than 2. As in, there's no real limit to how big it can be if it's bigger than 2. Where you'd want to sort of look at the limitations of what this answer can be, as in what are the overall numbers this can take on, aka what the range is, you start by looking at the most extreme number here, isn't it? The most extreme number over here is just 2, aka the smallest number. 2 plugged into here is going to be 2 times 2 plus 7, which is 11. It's never actually equal to 2, is it? But when it's equal to 2, it's the smallest possible number it can be. As in, if you substitute 2 into there, you get the number 11. It's never actually 11, but you get 11 when you plug 2 in. 2 is the smallest possible number you can plug into here. And do you see how that's going to create the range of f of x must be bigger than 11? We can't include that it's equal to 11. It's equal to 11 when it's equal to 2. It never actually equals to 2, but when we plug 2 into there, we get 11 as a sort of boundary number, isn't it? As in, it starts off by being bigger than 11. Guaranteed. Take a few seconds to process this if you need to. Ask me if you still are confused. But that's just the basics of domain and range. Domain is just going to be whatever number you can plug into the x value. Range is whatever number you end up getting when you say the domain is a certain range. Okay? When you say a domain is a certain set of values, just take a look at what this is in practice. If you have the range of a function over here, what we're focusing on right now is, you understand this is just an instruction for a function. So we have g of x equals to x squared minus 4x plus 1. What do we care about over here? Here's what's happening. Make sure that you can understand that the reason why, if we have, this is the domain then, isn't it? Do you see, without this over here, the x over here can be pretty much infinite, anything. It could be any particular number that we can plug into here, and it's going to create an overall answer. However, if we say that it has to be between 0 and 5 like this, greater than or equal to 0 or less than or equal to 5, then the numbers that we're allowed to substitute in here must only be numbers of what? Between 0 and 5. They can equal to 0, they can equal to 5, but they have to be between 0 and 5 overall. That's my point here. Do you see how, because you limit the numbers that go inside here, this overall answer is going to be limited? Think about it in this context too. If you were to plot this graph, which is what we have over here, why did we only include this portion of the graph? Think about it. If you were to plot this whole graph, you know it's going to be infinitely like that, right? Much bigger representation. It's like that. Why did we only stop here and here? Because if we say that x has to be greater than or equal to 0 and less than or equal to 5, we're only writing down what? It's only going to be plotted. Let's see where it is. That's 0. That's 5. Add 0 and 5 for the x values. This graph stops, doesn't it? Because that's the domain. The domain over here for the x, see this graph? We only have the x values between 0 and 5 now, and therefore we only have the numbers that x and 5, x is equal to 0 and x equals to 5, creates for the y values over here. So do you see the context? If you were to plot this graph, you see why it stops between 0 and 5, if this is the domain. And do you see why it stops at what? Between negative 3, because this is negative 3 on the y-axis, 6 over here. It is between negative 3 and 6, as in the y values it can take on for this graph now are between negative 3 and 6, which is why we have this as the range. As in, if you see this graph in front of you, you're not confused about why this is going to be our range over here. This is the domain they give to us, which affects what x value is allowed to be over here. Whereas previously, there was no real limitation to it, was it? Previously, you can replace x with anything right now. Previously, you could replace x with anything, but if you include this condition, which is the domain, you're telling what? X is only allowed to be between 0 and 5. Okay? So that's the domain, and the range is going to be whatever answer this is allowed to be now, when you say the number that replaces the x has to be between 0 and 5 like this. And this is where we get the range. If you didn't have the graph in front of you, how do you have to plot this? Like, how would you be able to find that? The way you'd be able to find that is if you rewrite this into the completed square form. Usually exam questions they'll get you in the first step to rewrite it into this form, so don't worry. They usually have multi-steps to it, and one of the steps will be you would have already rewritten f of x, or g of x in this case, into x minus 2 squared minus 3. You've already written down g of x is equal to x minus 2 squared minus 3 on an alternative form. And you see how in this form, it's very obvious to be able to tell what overall numbers this can take on, depending on substituting 0 and 5 into there will be. If you substitute 0 and 5 into there for the x, it becomes way more obvious than this is to seeing what the limitations are going to be. Pause the video if you have to sort of think about this, yeah? If you're not following, feel free to pause it. I'm recommending it to you. There's a lot of new concepts up here potentially. But anyways, if you understand that this is the same thing as writing this, then it means this is way more easier to interpret in terms of what this overall number is allowed to be. If you're saying the x that replaces this has to be between 0 and 5. And it just makes perfect sense. Do you see why it makes perfect sense to replace x over here with 0 and replace it with 5 to be able to see what those limitations are? Because why would you try anything between 0 and 5? Anything between 0 and 5, it's just too many possible numbers between 0 and 5. It's much easier to plug in the actual boundary numbers, 0 and 5. Because if you plug in 0 over there, you get 0 minus 2 squared minus 3, which is 1. If you plug 5 into there, you get 5 minus 2 squared minus 3, which is... See what happens? If you plug 0 into there, you get 0 minus 2 squared. You get 1, yeah? If you plug 5 into there, you get the number 6. Yes? So you know that it can definitely be between 1 and 6. But you also think about it this way, okay? If you substitute 0 into there, is that really going to give you the overall smallest possible answer? Because right now, if you plug 0 and 5 into there, you get the numbers between 0 and 6. And you might be thinking, oh, okay, if g of x over here is going to be between 1 and 6. That's not quite the case, because think about it this way, right? This number is the smallest when what? Does the minus 3 change? No. Does minus 2 change? No. Does the square change? No. Only the x changes. Do you understand? Because this is to the power of 2, the only smallest number this could be, this can never become negative. It's to the power of 2. The only time it's going to be the smallest possible number is when x is 2, because 0 is the smallest possible number this can be. This is what you must realize. So you realize over here that x equals to 2 indeed gives you the smallest answer. That's where you get negative 3. And that's where you realize instead of being between 1 and 6, it's actually going to be between negative 3 and 6. That's how you got the range. And you get why we write it like this, right? Because if you want to say that this overall answer has to be between negative 3 and 6, what other way could you possibly do it other than using these symbols over here? Does it make sense? If you're still confused, just message. Now take a look at this. Make sure you understand what this means. This just means x is an element of a real number. What it means in simple English is this, okay? If you had, say for example, this dumb fuck over here, we can call him Timmy. Timmy is T, capital letter T, right? Represents how many cigarettes he smokes on any given day. And remember how that sets work in IG? If you have curly brackets like this, T is equal to curly brackets like this. Say 2, 4, 2, 6, 7. This is implying what? If T represents the number of cigarettes he smokes on any given day, this means what? This is 5 particular days, isn't it? This is the set that represents 5 particular days, as in he was smoking for 5 days. First day 2, second day 4, third day 2, fourth day. Remember, math over here is just depicting relationships at the end of the day. This is how we sort of transcribe information. That's sort of the basis of math over here, right? We're trying to describe information. That's really it is. And you get that this is just how we use sets. My point is this, right? Do you see how if you write down 2ET, that's the notation from IG, as in 2ET is just the system we use to be able to say, oh, We're trying to show the information, hey, 2 cigarettes belongs to this group of numbers T. Because do you see how 2 belongs to this group of numbers? Some point. 2 belongs to this 5 numbers in a group. Yes. 4 element T. See how that works? So do you see how X over here, which replaces this number, is just saying X belongs to R. R is just the same principle as the T example before. It's just R is going to be every single number that ever exists. So do you see how X element R just represents, hey, this number over here has no limitations. It can be any number. Because R is just what? R is just the set of numbers as in all the numbers that ever existed. So if you say that X, which is a number that goes inside here, E, which means belongs to, this particular group of numbers, this particular set called R, real numbers, which represents every single numbers ever. I mean, surely that makes sense by now, okay? Anyways, because this doesn't have any limitations, what do you think this X is going to be? Do you see the relationship over here? It's X to the power of 2. This is where you realize, okay, if you're doing this in an exam scenario, you'd have this awareness. Anything to the power of 2 can only ever be what? It's not a coincidence now, is it? Anything to the power of 2 that has something very unique to it, what? The implication is it must always be positive. The smallest possible number anything to the power of 2 can be 0, when X is 0. So you think about these questions? You think about it in terms of what is the part that even changes? X is the part that changes. So if you have something that can be anything right now, according to this, X part of a real number, element of a real number, the number that over here can be anything, then anything to the power of 2, what is the limitation to that overall answer going to be? That's what range means. I'm explaining to you in sort of real time how you interpret this. What you understand is about range is overall, what is my number allowed to be? What is f of X allowed to be over here? So if you realize anything to the power of 2, if the number goes over here, it doesn't matter what it is. It can be anything right now, but it doesn't matter what it is because anything to the power of 2, the smallest possible number you get is 0. So how do you describe it? It can be any number as long as it's what? 0 or greater. Do you see X power of 2 just means it can be anything as long as it's 0 or greater. How do you describe that? Oh, bigger than or equal to 0. Because f of X represents a number now, doesn't it? F of X simply represents a number. The number you get when you replace X with a certain number over here and do it to the power of 2. This is why we write it in this system over here. It should make perfect sense. Okay? F of X greater than or equal to 2 just says that this overall X squared has to be bigger than or equal to 0. And that's true because if you replace a number over here, I'm done explaining that. You get the point, surely by now. Something over here for f of X is X squared plus 2X plus 9. The principle over here is, this might be a little confusing because you're not, it might look like you're supposed to know off the top of your head like what that can be, the limitation. But in reality, you'd be doing this in an exam in a way where they usually either give you the graph first or you'd have completed the square. Because when you complete the square, it becomes a lot more obvious. You'll find that when you complete the square for this, it's going to be X plus 1 bracket squared plus 8. And you'll find that if this can be X part of a real number, just means the X that goes inside of here, right? Because instead of looking at this now, remember, when you complete the square, it's much easier to evaluate, as in it's much easier to sort of see what the overall limitations of that answer can be. If you are saying the X that goes over here can be anything, 8 doesn't change, plus 1 doesn't change, to the power of 2 doesn't change. But the number over here, because it's part of X plus 1 to the power of 2, we realize anything to the power of 2, the smallest can ever be is negative. And if this number can be anything, that means what? When it's negative 1, it's going to be the smallest possible number over here, which is 0, right? 0 plus 8. Therefore what? 8 is going to be the smallest possible number it can ever be. How do you show that this overall answer can be anything as long as it's what? Either 8 or greater, bigger than or equal to 8. This one over here, you substitute negative 1 in and you substitute 4 in. See how that works? If you substitute 1 into there, you get the answer 1. If you substitute 4 into there, you get the number 16. But you don't just willy-nilly start writing down between 1 and 16. You'd realize what? Because it's the power of 2, we always know what? The smallest possible number for x power of 2, because we never look at what the biggest possible number for x power of 2 is. There's no real limitation to what the biggest number x squared can be, but there is always a limitation to what the smallest number can be, isn't it? Which is 0. Can this ever be 0 over here? Is 1 really the smallest, or do we realize when x is 0, because 0 is between here and here? Remember, recap over here, we're saying the x that goes inside over here has to be between negative 1 and 4. It has to be between negative 1 because that's the definition of the domain. Because without this, you'd think this can be anything. You can replace this with anything. But with this, aka the domain, you cannot just replace it with anything now anymore. You must follow this particular instruction, this particular scope, this limitation, which is saying the number that goes over here has to be between negative 1 and 4. And you realize when you substitute negative 1 into there, that doesn't actually give you the smallest possible number. It actually is what? When you substitute 0, which is between this region that's allowed, 0 squared. 0 is the smallest number. So it's actually going to be between what? Between 0 and 16, like that. And you know why we do the equal sign, right? It's because it can actually equal to 0. I mean, are we allowed to substitute 0 into there is my point. Do you know how to interpret the domain by now? Domain, by now, you should understand that, hey, if we have f of x equals to x squared, are we allowed to replace the x with 0? Yes, because it's between negative 1 and 4. Are we allowed to replace the x with 1? Yes, because it's between negative 1 and 4. Are we allowed to say f of x equals to 25? Fuck no. Why? Because when does it equal to 25? When x is 5. Is x allowed to be 5? No, because it must be between what? Negative 1 and 4. See the significance of this? It's just the awareness you need to have when you interpret these questions. These are the basic building blocks. If you're doing function questions, 5, 6, 10 mark function questions, and you're wondering, like, you look at a solution, it's not that you're dumb. You don't have the basic building blocks of it. Like, you don't know how to even... You just look at a function, you're just like, what is this? Yeah? This is what you're missing over here. It's a basic definition of domain and range, knowing how to interpret what you see in front of you, and understanding that domain is just, you're limiting what number you can replace the x with over here for this overall instruction, which is what a function is, and the range, which is overall the answer you end up getting if you were to limit the number you plug inside over here. This is the basis, okay? Now you look at 1 divided by x. If you're saying x can be any number right now except for 0. By the way, what happens when x is 0? Type in 1 divided by 0 in your calculator. See the problem? 1 divided by 0 doesn't give you an answer, yeah? You can't do anything divided by 0. So my point is over here, do you realize why they wrote x cannot be equal to 0? Because if they don't write any of this shit, yes, if they just wrote x part of a real number, and you end up substituting 0 into then you got a math error, that wouldn't be true now, is it? Because it's saying x can be any real number, any number ever. You can't just substitute any number in here. They have to also include what? It can't be 0. Otherwise, it wouldn't be mathematically true. There's no statement in math that isn't 100% true. If you're going to make a statement in math, this is just the basics over here. You understand? If you're going to make a statement in math, it better be 100% true. There's no such thing as like a partially true statement in math. There's no such thing. So if you're going to say x is allowed to be any real number over here, you better make sure what? It is indeed every single real number. In this case, it's not just every single number ever that can be there, because it can't be 0, so you have to include that what? You have to include it can be any number, but also what? Cannot be equal to 0. And you realize because it can be any number over here, it's just going to be between what? It can be any number ever. It can be any number ever except for what? Except for 0. Do you know why? I'll tell you why it cannot be equal to 0, okay? It cannot be equal to 0 because if you do 1 divided... Like, when does f of x equal to 0 over here? Think about it. If you wanted to... Let me show you an example, okay? If you wanted to do 1 over x equals to... if you were to write any number over here, you'd end up being able to solve it for x. You could never to solve it. You could. I'm serious. If you wanted to do 1 over x equals to any number over here, you could rearrange and get x is equal to what? Whatever 1 divided by that number is. Whatever you put inside here. 1 over x equals to 420. Can you get what x is? Oh yeah, it's solvable. It's just 1 divided by 420. If you don't know this, you shouldn't even be sitting in the exam, okay? If you don't algebraically understand 1 over x equals to 420, and that x is equal to 1 over 420, you are in the wrong subject, okay? Yeah? Do you get that? If you were to make this equal to a really big negative number over here, you'd be able to solve that. You see what we're trying to show you over here? We're trying to show you that if you were to make f of x equal to a particular number, there is indeed a certain x value that you can find for whatever number you put over there to make it true. AKA the range, because remember the range is telling you what overall this answer is allowed to be. Take a few seconds, pause this if you need to. This is so important. It's true for every single number. You can make this equal to any number and end up solving it for x, except for what? If you do 1 over x equals to 0, fundamentally you cannot find any number to do 1 divided by to give you 0. If you were to rearrange it, you just end up with what? X to the side is just 1 is equal to 0. What the fuck? That don't make sense now, does it? But you also fundamentally understand that 1 divided by a particular number equals to 0. Huh? You know? See the points? There's no number you can actually do 1 divided by to give you equal to 0. If you do insist on knowing what the answer to this would be, it's infinity. Only 1 divided by infinity is going to be equal to 0. Can x equal to infinity? There's no such... Like, we know what infinity is. We can fathom it. Hopefully you can fathom the concept of infinity. But infinity is not a number now, is it? So I'm sure you understand by now. Hopefully. Okay? After all that, you know why the range is just... It can be anything except for 0.